Okay, so before we start talking about the binomial theorem, please make sure you watch the TED Talk on TED-Ed. It's a great introduction to the binomial theorem. So we're going to go ahead and start with what is a factorial symbol. The factorial symbol is the exclamation point. What it does is it multiplies all whole numbers from that chosen number down to 1. So 1 factorial just is 1. If it was 2 factorial, 2 times 1. 5 factorial, it would be 5 times 4 times 3 times 2 times 1. And n factorial would just be n times n minus 1, n minus 2, all the way down to 5, 4, 3, 2, and 1. Now we need these factorials for what we're going to talk about next, and what we're going to be talking about next is what combinations are. Now combinations can be written 2 different ways. One of them is NCR, or n over r in parentheses like this, right on top of each other. And again, it's read as n choose r. Both of them, n choose r. Now the formula for doing this is equal to the top number factorial all over r factorial times n minus r factorial. But do know there is the n choose r button and the npr button in your calculator, along with the factorial symbol. So you're going to have to go through and find where that is. Each calculator is a little bit different. Now we're going to go ahead and write out Pascal's triangle, which we will go ahead and need. Pascal triangle starts off with 1, and then 1 and 1, then 1, and what you're doing here is you are adding 1 plus 1 to give us 2, and then 1, so the next column will be 1, add 1 plus 2 together to give us 3, 3, and then 1, and 1, again add 1 and 3. For this one it would be 6 because you are adding the 3 and the 3 together, 4, and then 1. Now, this also can be true for combinations. That would be 0 choose 0, 1 choose 0, 1 choose 1, 2 choose 0, 2 choose 1, 2 choose 2. And then the next row would be 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Now, some rules that you need: if you ever have any number over 0, is always going to equal 1. Any number over 1 will always equal that number, and any number over just 1 less than that number will just equal n. So we're going to use Pascal's triangle in this idea of combinations when we're using the binomial theorem. I know I mentioned it before, but it's going to be very helpful for you to watch that TED Talk that I have posted on the same page as this. All right, so let's go ahead and talk about expanding binomials. And binomials are anything that is in this form, x plus y to the n power. So if it's to the 0 power, it would just equal 1. Now, if it was x plus y to the first power, that would just equal x plus y. If it was x plus y to the second power, that is equal to x squared plus 2xy plus y squared. And if I do another one, x plus y to the third power, that is equal to x to the third plus 3x squared y plus 3xy squared plus y to the third power. Now, let's take a look at the coefficients. The coefficients in front of this would be 1, 1, 1, 2, 1, 1, 3, 3, and 1. And hopefully you see that pattern emerge that is the same as Pascal's triangle from all of those coefficients. The other thing to note is that x to the third is your first term, then it's going to be x squared, then x to the first term, then 0 x's. And y's work exactly the same way. It's y to the third, y squared, y to the first, and then y to the 0 power. So when we're going through and doing this, this is the binomial theorem. So we're going to go ahead and now look at the binomial theorem. And the basic of that piece is based on this idea that any binomial you have, x plus y to the n, will equal the summation from k is equal to 0 to n of n choose k, and that's what we talked about on the first page, of x to the k power, y to the n minus k power. Now that's just the actual binomial theorem. But I think if we go ahead and look at an example here, it's going to make a lot more sense to you. So let's go ahead and start with the example of x minus 3 to the fourth power. So let's first start with x. So we know we're going to have this be x to the fourth, then x to the third, then x squared, then x to the first, and then x to the 0 power. But remember, x to the 0 power, that's the same thing as saying 1. Now, let's go backwards and look at 3. We're going to start with a negative 3 because we're going to need all of this. If the x would have had a coefficient, you would have needed to include that as well. So that's going to become negative 3 to the fourth power. This is going to be negative 3 to the third, negative 3 squared, negative 3 to the first, and negative 3 to the 0 power. But again, anything to the 0 power is the same thing as 1. So what we just did was x to the k in this case being 4. So I'm going from 4, 3, 2, 1, and down to 0. Then we do the same thing with the negative 3, but we're going in opposite order, so it's 3 to the 0, which is 1, negative 3 to the first, negative 3 to the second, negative 3 to the third, and negative 3 to the fourth. So the next part that we need in this formula is this n choose k. So for n choose k, because we have to have the coefficients here, so now I need n choose k. So I just start with the 4. That's the exponent that I'm trying to expand it to. So that's going to be 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and finally 4 choose 4. Now in between all of these, let's going to go ahead and we're going to just put a plus sign to recognize right now that those are all separate terms. And then just watch the negative signs on the 3 because that will change things. So 4 choose 0 is 1, so that becomes 1 x to the fourth. 4 choose 1 is 4 x to the third times a negative 3. so I just completed my first term, my second term. Now I'm over here on my third term right here. So I have 4 choose 2, which is 6. That is still x squared times negative 3 squared, which is 9. So the next one I have, I'm doing is 4 choose 3, x to the first, and then negative 3 to the third, which gives me 4x times negative 27. So 4 choose 4 is equal to 1 times 81. Oops, that's a plus sign there. So let's go ahead and take a second to look at those combinations. Those combinations I got are 1, 4, 6, 4, and 1. Those all came from the combinations of 4 choose 0 is 1, 4 choose 1 is 4, 4 choose 2 is 6, 4 choose 3 is 4, and 4 choose 4 is 1. There's another place I can find that, and that other place I can find that is just Pascal's triangle, right? So it is the 4th row, which is 4, 1, 4, 6, 4, and 1. And I use the 4th row because of the fact that I'm expanding this, and n is equal to 4.